everybody. Today we're going to be discussing the address operator and how a basic integer is viewed inside of memory. And then you can kind of go from there on how data types are viewed in memory. Hopefully this helps. If you already know how this works, it won't help you. However, if you don't, then it will help you. Let's go ahead and rerun the program. I'll go ahead and clear my screen. As I run the program, as you can see, there is this hexadecimal number followed by, this is 4 bytes. So I come down to my program. Inside of my main here, I have my integer variable named number in memory, which is assigned to 10, and my semicolon, that is my syntax. And then I come down to my cout statement with my stream insertion operator, followed by my ampersand sign and my variable name, number in memory, stream insertion operator, and my endl. So my ampersand sign, and which is also called the address operator. So I come down to my cout statement. This is my stream insertion operator, string literal, stream insertion operator, my size of, if you haven't already seen it, I have a previous video of my size of. This is just showing how many bytes that this data type in particular is holding. As you can see, I've used the name of my variable to determine the size of that variable, which is number in memory, and followed by the word bytes in my next string literal, stream insertion operator, string literal, stream insertion operator, endl, and my good old semicolon for my syntax. So that was a little fast. So hopefully let's break this down a little bit. So as you can see, if you're not familiar with this, so this is going to be my integer variable named number in memory, and it is assigned 10. So if I rerun my program, I'm not going to get the same number as I did previously, this hexadecimal number, and I'll show you that. At least it's not likely. So let me go ahead and clear my screen. I rerun my program here. And as you can see, I got a different number here, which is great because that's what I was expecting. The number doesn't really matter. Really, why? Because it just doesn't really matter at this point why that number is the way it is. Just know that it is a hexadecimal number. If we're going to use an example, though, and draw you an example, so this is going to be my data type. This is my variable name. In this case, I'm just going to use num so I don't spell it all out. And then I'll use my assignment operator, a different one, and then I'll go back to my data type since it's an integer. And my syntax, so I'll keep that again with my semicolon. So here is my variable. If I were to view this in memory, it actually is similar to an array. It doesn't go up. It actually it can go up, but it's similar to an array. So it's going to have boxes, and basically that this number is assigned one of these boxes inside of memory somewhere in memory, and it's given a number. Once it's given a number, then that's going to be its address inside of memory. So basically, if it was an integer in this case, it's going to have a box, and then it's 4 bytes, and it will break down into 4 pieces here. And then it'll have its hexadecimal number here, as you can see here. We can go ahead and copy that. Oh, sorry. Go ahead and copy it. And then we come down here. So I'm going to have my I'm going to have my hexadecimal number. So these are actually going to go in 4 numbers here. They're going to work up to 4. So whatever this number is, it would be 3 numbers back or 4 numbers forward. I'm not really sure actually which one it would be. Just know that it is going to be 4 bytes, which is equivalent to 32 bits. So that is your integer. So again, so we have an integer, and then inside of this box, we have those hexadecimal numbers in each side. And then we have our number. Let's try to make this like a really bright number. Let's see. 10. And it's an integer, which is 4 bytes. Or 32 bits. If you have any questions, please let me know. Thanks for watching. Please like, share, subscribe, and let me know if you like this content, and I'll keep going. Thanks again for your time.